So at the time of this recording, it's morning. So good morning all. My name is Nakul. I'm from Nehru College of Engineering and Technology from Coimbatore. And this is my explanation video for a problem statement given by Smart India Hackathon as well as the Department of Earth and Science. The problem is development of a sensor for the detection of microplastics. So this is a common and a relevant issue right now due to the increase of development and increasing use of plastics. It is getting really out of hand, and plastic is taking many forms, and it's in our waterways, in our food, everywhere. So our sensor mainly detects microplastics in water. We have taken this idea because it's I believe it's a really relevant, and so we have taken this approach in our own way, in our own innovative way, as well as we have taken many references from research papers, and we have studied it all and combined this idea of both the research papers and our idea to make this our project. This is a topic of the utmost relevancy because of the fact that this causes a major problem in human health, as well as it pollutes water bodies, as well as it destroys nature as its own. This is because of the fact that this is a non-biodegradable material due to the fact, and it's made of silicon as well as many other chemicals. When these microplastics enter our body, it destroys it from inside out. It causes cancer and many other things. And I believe what we did is, our innovation for this is, we created a sensor that is actually like a best counterpart for the current methods, that is Raman method and FITR methods. So our method is kind of basic +2 physics, as it just uses light attenuation as well as sensors and a light diode. So the fact that we can use something as simple as +2 physics for a really big problem says a lot about this project right now. And what we did is we created a sensor which uses a low cost diode as well as a LED. When water sample is kept under these LEDs, light ray of a certain wavelength will pass through this, and what it does is, a light diode that is kept directly under this, that is a photodiode, collects the light which has already been passed through the sample, and it collects the value of light. When the photodiode collects this value, it directly passes through a filtration test, which filters the noise captured by these light samples and converts into electric signals. When this electrical signals is passed through a Raspberry Pi, it calculates the absorbance value using a basic formula, that is the Beer-Bernoulli's formula. And after this, the calculated value is passed through a GUI, in which when the values pass through this GUI, a microscope of high resolution will act upon the sample, taking high quality images. And when we take these high quality images, we use image processing like OpenCV and Pillow, and we use this to locate the exact position of these microplastics, and we pass it through a GUI where we both show the value of both the detected particles taken from the microscope as well as the value which we have gotten from the light diode, that is the absorbance value. And our approach for these problems are, it is a really cheap and it's really portable, and it's a hell a lot precise, as due to the fact that we take each of the testing takes around 14 seconds, and it's a really smart method. And the results of this data from its counterpart, it's really fast due to the fact that we take around 10 seconds, whereas the counterparts take around 2 days. Like, it's a laboratory setup and all. So what this does is that we can take this we can take it anywhere. We can go from villages to villages. We can take it from research stations to another research stations. This is why we made this idea. We taken a lot from research papers, as well as the portability is our idea. So as for the technological sides, we use a Raspberry Pi of 8 GB RAM. This acts as a brain of this system, and we use LEDs of 370 to 940 nanometer of wavelength, as well as we use a photodiode with an amplifier and a filter to filter the noise and make it strong. We use an amplifier to make the signal strong, because when we convert these light samples into electrical signals, it will be slow, and it contains a lot of noise, electrical noises. So what we do is we use a filter to filter out the electrical noises, and an amplifier to strengthen the signal. And we use a stepper motor and A4988 drivers. What this does is, this rotates the sample across the light rays, so that the light rays reach every part of the sample. So we can detect not a lot, but every part of this water we can detect microplastics in it. And we use a high resolution microscope. This microscope captures high resolution images, and we also use a GUI interface which runs the Python OpenCV, that is the image processing unit. And so let me explain the methodology, that is the step-by-step process. When we keep a slide of water, we use a quartz corrugate. What this quartz corrugate does is, it doesn't absorb light as much as any other corrugate or slides. So when we keep water sample in this quartz corrugate, that is and directly under the LEDs, the light bulbs, when we press activate, the light bulbs will release a light of certain wavelength to the device. And when light is released from these bulbs, a photodiode that is kept directly under the sample slide collects these lights. That is, when light passes through these samples, microplastics absorb a lot of material, a lot of light through it. A photodiode collects these light samples, and what it does is, it sends it directly to the brain. When the first sample results is directly taken to the brain, the stepper motor will work, and it will rotate this slide in part of the light way. That is, it directly moves the slide across the light, so that we can detect it from anywhere. And when Raspberry Pi calculates the value, what it does is, it initially takes the value of the light that is emitted, as well as it divides it by the light that is absorbed by the photodiode, and we get an absorbance value. Now what happens is, when we get the absorbance value, a microscope is activated. This is a high resolution microscope. This microscope scans the water sample and takes high resolution photos, and these photos are put into a open source software that we use is OpenCV or Pillow for image processing. When this image processing unit detects the exact number of particles, it shows a graph which represents the amount of concentration and absorbance value in the GUI interface, in which we will get the value of the concentration, that is the amount of microplastics in the sample. So why this is a really important as well as a really good method is that it is really cheap compared to all the alternates. So for the feasibility and viability, it is very much feasible, as because it's really portable, and it's the energy source of this project is because it's efficient, and we can use a rechargeable battery as well as solar lights. And there are certain challenges we faced during the making of this project. That is, the filters. Whenever we remove the filters, we get noise from the ambient light, as well as the calibration of different polymer types. For example, the plastic of different sizes, we get different values for it, and sometimes it doesn't differentiate from the organic matter, as well as that made a huge risk for us, because whenever we remove this organic matter, water loses its minerals. So for the solving of these problems, we use a digital image processing as well as the optical filters which shields the samples results. So for the impacts, it is a really low cost method, as well as when compared to the other alternate methods. It's a really low cost, as the production of one unit costs around 15,000 rupees, and it's really easy to use, as everyone can use it. You don't have to be a researcher or scholar to use it, and we'll get faster results, and we'll get the results in around under 10 seconds. As with the right amount of appropriate technology, we can scale it to a higher level. That is, we can use AI for detection, we can use a lot of stuff for detection. And as for the benefits, we can get a safe drinking water. We can detect some things in this water, that is a microplastics. We can detect it, and we can treat it. So we'll get a safe drinking water. It will protect the environment, and we can detect it from anywhere, and it can also support researchers for a lot of things. Thank you.